Hi. All right, we are just going to run through a couple of example problems real quick. Not really going to give a whole ton of context or spend a lot of time, but we're just going to run through some of these things from Chapter 11. So a band director has to choose 4 songs for the spring concert. She'll decide the order of the songs later. That phrase is in there to tell us that the order does not matter, that she chooses them. The band knows 9 different songs. How many different programs could she create? Well, there are obviously going to be no repeats here. So this is not FCP. Order does not matter. Order doesn't matter. So we have a combination on our hands. So of 9, we are going to do combination 4. Again, everything for probability in the calculator is on the probability tab on the in the math button menu. So 126 there is the would be the answer for how many different programs could be chosen, or how many different sets of 4 songs. Next, 32 soccer teams participate in the World Cup. How many different ways could gold, silver, and bronze be handed out? Because we are specifying gold, silver, and bronze and not just the top 3 teams, obviously we can't have a repeat team win all 3. And the order does matter because gold versus silver versus bronze are very different things. So we're going to go to math, probability of, and then do a permutation of 32. I want 3 teams. So it's going to give me 2, 9, 7, 6, 0. I'm going to let the dog in. Hold on. Yes? Can I help you? Hi. Asher? Come here, everybody. No? Okay. Sunday morning. Okay. What else we got? Oh, so 29760. How many different meals can be created from 4 appetizers, 6 entrees, and 3 desserts? So it's not stated here, but we're going to assume that we are doing one of each of those categories. So I have an appetizer to choose from. I've got an entree to pick. Then I have a dessert. So again, like this is not going to be a permutation or a combination. We're just going to fill out the number of possibilities in each category. So I got 4 appetizers, 6 entrees, and 3 desserts. Multiply all those together. I get 72 different meals that could be chosen. So that is the third way of counting possibilities very quickly. Then we move into some probability stuff. A bag of M&Ms contains 12 brown, 8 blue, 11 red, and 6 green. So that's a total of what? 20, 31, 37. Yeah, hey, buddy. Come up here for a second. Say hi. Say hello. Do some math. Nothing? Shake. Asher? No. I see you, Magnolia. Okay. You want to do the math? You're not very helpful. Give me that look. You know we're recording, right? Wasting everybody's time. YouTube wants to know. Asher, help them. Okay, well, thanks for that. Oh boy. Okay, so 37 M&Ms in that bag. What's the probability that I pick a brown or a blue one? Well, there's 12 browns and there's 8 blues, so that'd be 20 out of 37. I'm not even going to change it to a decimal. You can type it in the calculator if you want. What's the probability I pick a brown and a blue one? Now the key here is I'm only picking one M&M. Okay, so if I'm going to pick one that's both brown and blue, this is not possible. That would be 0 out of 37. What's the probability I pick one that's not green? Well, there's 37 in the bag, 37 total in the bag. 6 of them are green. So that means 31 would fit my description of being not green. So 31 out of 37. What's the probability that I pick a M&M that is red and not green? So if you think about this, if this has to be red and not green, could be blue, brown, or red, right? Obviously, in order to be and, it's got to be both categories. So this question is just asking, what's the probability that you pick a red one? So it'd be 11 out of 37. Again, type some decimal in if you want. We'll call it good. So it was 1 if you're only choosing one item from a bag. Similar question, but now we're drawing 2 Skittles from this bag without replacement. So it means after we pick the first one out, it is not going back in the bag, and thus it will change the numbers or change the sample space that we have. 13, 9, 10, and 3. 13 red is 22, 32, 35. So I got 35 total. What is the probability that you draw red and then red again? So I've got 35 in the first draw, and then there will be 34 in the second draw. 13 out of 35 reds, and then that red is out of the bag, so that means this is going to go down to 12 out of 34. I'm going to go ahead and type those in. 13 out of 35 times 12 out of 34 is 78 out of 595, or might be useful to have a decimal here, 0.131. So there's a 13% chance that you go back-to-back reds. Oh boy. My gosh. Okay. What's the probability that you go green then yellow? So again, my sample spaces are going to be the same. 35 for the first draw, then 34 for the second draw. I'm going green, which is 9 out of the 35. And then after I draw a green one out, all the yellows are still in there, so it's still going to be 3 out of 34. So 9 out of 35. 35 times 3 out of 34. This will obviously be a smaller answer because the numerators are way smaller. 0.022, which as a 27 out of 1190, or 0.022. I guess technically 0.023. So that would be the probability of going green then yellow. And this is the interesting problem in this situation. The last one says, what's the probability you draw green and orange? And it's one tiny word, but it is really important. The fact that it says green and orange, and it doesn't say green then orange. So this problem isn't specifying an order. I know the word green is written first, but this is just saying if you pick out 2, what's the probability that you have a green and an orange? So what we have to do is we have to go green then orange and add that to orange then green. Okay. So we're going to set up 2 separate problems here. So if I'm going to go green first and then orange second versus orange first and green second, as you can imagine, these are going to be the same answer individually because all that we're changing is the order of the numerators. But that doesn't really matter since we are, right, like either way you're going to end up, when you multiply those fractions together, you would have 90 over whatever 35 times 34 is. So what I'm going to do is do 35 times 34. So it's 1190, which means if I go here quick, this would be 90 over 1190 plus another 90 over 1190. It's going to give me 180 over 1190. We're going to go ahead and I know that 180 over 1190 is 0.151. 0.151, or as a fraction, 18 over 119. Okay. It might seem like a small thing, but the fact that this third problem does not specify order is actually really important, because we do have to double up that probability, because it could go either green, orange, or orange, green. Okay, use the two-way tables to find the probabilities. Find the probability that someone plays video games. So I'm going to total these up quick. So it's going to be 65. Hopefully I don't mess this up. That's 50. So it gives me 115 total. 71, 44. That's also 115. So plays video games. There's no given event. So I'm drawing from all 115 people. Of those 115, how many play video games? Okay, so I'm looking at this n number of 65. So 65 out of 115. That would reduce to 13 over 23, which is a decimal. Okay, 0.565. Okay. And then, how about what's the probability that someone reads given they do not play video games? So you know they answered no to playing video games, which means my sample space is 50. Of those 50, how many do read for fun? That'd be 20 out of 50, which is 2 out of 5, or 0.4, or 40%. Okay, so that's how we use that two-way table to answer some questions. Here's a already filled out tree diagram. So it looks like the first thing is if you study greater than 1 hour versus if you study less than an hour. And then do you pass or do you fail the test? Okay. So find the probability that a student passes the test. So that means I got to double up here because there's that path to pass the test. Then there's this path to pass the test. So I got to multiply these together. I got to do 0.6 times 0.85. Do that right away. 85. 0.51. Heads in the way. 0.51. And then what if they study less than an hour but still pass the test? That is 0.4 times 0.55, which is 0.22. 0.4 times 0.55 is 0.22. And then I'm going to add those up. So 0.51 plus 0.22, there's a 73% chance that I pick someone who passed the test. What is the probability that they study greater than an hour and fails? So again, if you see the word and, normally that means multiply. And in a tree diagram, that holds true because I'm going to study greater than an hour but still fail the test. So it's going to be 0.6 times 0.15. 0.6 multiplied by 0.15. That's going to be 0.09. So there's a 9% chance of choosing someone who studied greater than an hour and failed the test. So tree diagrams, hooray. And that's it. Okay, well, bye.